Hi, welcome to another edition of Antique Radio Archaeology. Today we're going to do a continuation of our test equipment series. I'm going to restore a RCA WV-77E vacuum tube voltmeter, VTVM. Before I get started on this restoration here, I'd like to explain a little bit about why VTVMs are important in radio troubleshooting and repair. Back in the early days, you had what was called an analog voltmeter. As a matter of fact, this is a Simpson model 260, which is a typical analog voltmeter. The nicety of it is it uses batteries, so you're not hooked to house mains when trying to do any kind of troubleshooting. But it has its limitations. The biggest one is the input impedance on these things only runs around, on this one it's actually about 20 ohms. Most of the lower end analog voltmeters are about 10K. The vacuum tube voltmeters are up to about 11 meg. So circuit loading when you're trying to do testing is very, very minimal with a VTVM, whereas this will load down a circuit and you'll get erroneous readings, especially on lower scales. These meters were used pretty much throughout the history of radio, but in the 50s solid state technology started taking off. Along with solid state technology came the problem of very low impedance circuits. As such, you are having the problem of circuit loading with the analog voltmeters. So in order to prevent that from happening, VTVMs really took off. And you had a lot of manufacturers. Heath Company put out VTVMs, Hewlett-Packard, all the major test equipment manufacturers had their own version of the VTVM. And it's called the VoltOhmyst, by the way. It's actually a very popular meter. It was also kind of a low-cost meter, so they took some shortcuts when they produced this meter. This one here is 1960 model. It's about 1960. But it wasn't until later on in the 60s that they started producing a meter like this, and this is the Simpson Model 313-3 solid state volt-ohm milliamp meter. What this is actually like a VTVM, only it uses solid state electronics inside of it. The other advantage of this, because it's not using vacuum tubes, it can use batteries, and as such it became kind of a hybrid between this and this. It has the same type of impedance. The impedance on this is about 10 megohms. The other thing about VTVMs and even the FET volt-ohm meters is the fact that the resistance measurements, they can measure higher resistance. Today, the most popular type of meter is probably the digital multimeter. One of the things that's actually kind of interesting is these things have a very high impedance. So these can be used in place of a VTVM. The problem that you run into now, basically what you're dealing with is numbers. You know, when you're trying to peak, try to get the max voltage out of a circuit while you're doing an alignment, it's really hard to follow numbers that are constantly moving around. Whereas with a needle, you can sit there and get that top of the scale reading that you're looking for. But these things have pretty much replaced the vacuum tube voltmeter in the electronics world, but they are still useful to have a VTVM because, like I said, doing radio circuit alignments and things like that, these things are just undeniably useful. The biggest disadvantage, of course, is being on house mains. You have to be very, very careful how you place your probes because you don't want to create a ground loop where you're going to either fry the equipment under test or even the VTVM, although these do have fuses in them and circuit protection, but still you don't want to ever get to that point because you can cause damage to either or. So let's go ahead and tear this thing apart and see what we got to deal with. As you can see, big problem I have is this has those cheesy little sockets. I'm going to replace those. That one's broken. I'm missing my knob here. There's some rust on the case. And it does have a little test lead holder up here, and I guess you can probably even coil up your power cord there. But right off the bat I can see that I do have, I'm not even going to power it up because I do have, that's broken. I don't know what I'm dealing with on the inside. So let's go ahead and pull this apart and see what we're dealing with on the inside. I would like to go ahead and make this thing electrically sound before I try to plug it in. Oh, okay. Alright, there we go. I got a little bit of rust inside here, I can see. Oh, this thing's been worked on. That's disconcerting. First problem. Definitely see an original. This actually looks like the original battery that was in it when this thing was probably first made. Wow. I'm reading 1.2 volts. Yeah, still going to replace it. Definitely don't want to keep that in there. So it should be 1.5 anyway. I see I have a wax capacitor there. An electrolytic right here that needs to be replaced. There's one of those caps there that need to be replaced. Oh my goodness. Well, I don't know if you can see that very well or not. I have to put a flashlight on it. Yeah, down inside there, that capacitor is it's not even attached to the trace. But I got a couple fuses. One there, or a fuse. It's got the selenium rectifier, which if this was a radio I would replace it, but since this thing probably won't see much use, I don't mind leaving that in. But I see 1, 2, 3 capacitors that I definitely need to replace. And I'm going to definitely go through the replace these lead sockets. There's our calibration pots. I'm sure I need to clean the pots and things like that, but yeah, got a few things to do before we fire this up, so I'm going to go ahead and see if I can get the parts together. So I went ahead and I got some capacitors. I got a 0.047 capacitor. That's going to replace that one. This one's 400 volts, this one's 650. Got a 650 replacing the 600 volt 0047 capacitor. And then I got a 10 microfarad 450 volt electrolytic that's going to replace that one. So I got my capacitors, I've got a new battery. Also got a new power plug. This one's not in horrible shape, but I just would rather have a polarized plug. I like the hot side going to the switch. So that'll take care of that, and then I'll go ahead and I'll clean up that solder connection. So first thing to do is to get this thing pulled apart. All right. Oh. Be careful not to break that wafer switch. I think the best thing I could do is pull the meter. That'll give me some room to work with. Yeah, let me do that. There we go. Okay, so here's my meter. Okay, I just got a delivery. Looks like I got my terminals. Yeah, this will work. Need a blue one, black one, and a red one. I'm going to replace all three. Fortunately, it looks like I'm going to have to drill out those holes a little bit. Yeah, they look a little too small. Yeah, they are. Shoot. Well, that sucks, but hey, you know, needs to be done. Perfect. Okay, so there we go. All right. There we go. Alright. This capacitor, I can go ahead and pull that lead out. Now, one of the things I noticed, I got my two holes done, is that hole there, I got a problem. The trace is gone. So, what I need to do is I need to leave enough wire on this side of the capacitor come over here and hit that component right there. So I actually need to solder it to that. But alright, there's the cap. My 10 microfarad 200 plus minus. my electrolytic. Oh, there we go. That'll work. That's it for the component replacements. Okay, so I've disassembled this. I pulled the handle off of it. Nothing but screws in the side here. I took a wire brush using a Dremel tool and I got in there and got all that rust out. A little bit there. Got the inside already. So what I'd like to do is just clean this up and polish it. And I'm going to need to wire brush this, I think. It looks clean underneath the thing, and this is flexible enough. I just need to clean that up a little bit. And of course the faceplate as well. I want to get that nice and cleaned up. And the meter, I have to watch out. It is cracking here. Around there, here. Yeah, these things crack very, very easily. You have to be real careful with them. So, keep that in mind. So I'm going to go ahead and drill these out and we'll get started on the cleaning. Perfect. Now typically you don't use anything with ammonia on plastic, but this is just, I do it very, very seldom, but when I do, it's usually because there's a lot of grime. It's just impossible to get off. This is just alcohol. This is just car wax. Just using old turtle wax, actually. There you go. Looks a lot better. I'm going to go ahead and try and get all this gunk off of here using Goo Gone. That's something that works. This is acetone. I hate using that because I don't know if there's a coating on here, but it doesn't seem to be. And it's doing a real good job of cleaning it up. I don't want to get it around the printed stuff. That should be good enough. Alright, so let's get this case cleaned up. Okay, when things get tough, you get tougher. This is, yep, toothpaste. It's a mild abrasive, and it'll work on really stubborn stuff like I'm dealing with right here, without damaging the finish too much. I mean, it might haze it a little bit, but I'm actually going to take care of that here in a little while. Oh yeah, much cleaner. That's actually looking good. Okay, I'm going to put a little bit of rubbing compound on this, kind of get a little bit of a shine to it. Now, I didn't have to repaint it. I'll go ahead and put some car polish on it, and that will complete this portion. Alright, I'm going to let that sit for a little while. Now I'll give it one last polish and we'll be done with that. Okay, so for this, I'm going to just use some steel wool and Goo Gone. Alright, there you have it. Okay, before we start putting this thing back together, I'm going to get in here and start measuring some of these resistors. Most of them I should be able to read. 322.4 should be 320. That's good. That's within specs. All right. That should be 900K. 910K. Okay, I'm just going to continue. I'm going to hit every one of these resistors. There we go. 100K. It's 99.7K. Alright. I'm going to go ahead and hit all these resistors. Make sure that every one of them is within tolerance. All the resistors check out great. Now, the one thing I do want to do is I do need to clean these pots. Just a little bit, that's all it takes. I'm going to get in here and I'm going to clean these contacts on these switches the best that I can. After the wiper. Do a little bit of a strain relief there. Now, the thing about a strain relief is I can adjust it later if I have to. There's the hot. There it is. Okay, so that's the hot end. Hot's always the narrow one. That's the ground, or the neutral. Not ground, neutral. May not be able to make take it. Then again, maybe. Ha, there it is. Okay, that is good. There we go. All right. So, got power. Alright, one of the things I want to do, I do want to put some Loctite on all of them. Now, if you don't know it, Loctite is actually super glue, for the most part. Okay. I'll go ahead and get this meter in here. Alright, so. Don't want to make it too tight. Remember, that's very fragile plastic. Okay. Try not to do. Spare parts, yay! Actually, when I was back in the day, when I was a consumer electronics tech, there was another technician that worked on the bench next to me, and he had just boxes of spare parts, and I don't even want to tell you where they came from, because I've learned that every screw has its place and you shouldn't have leftover parts, but he didn't think that way. Sadly, I meant his customers kind of got the shaft. Alright. Okay, I think that's on there. It's not coming off. Alright, I gotta get that lamp positioned correctly. What I'm trying to do is that lamp has to go under this copper bracket, and I'm trying to get it positioned to where it will clamp it, which I think I just did. I finally got it. It took me a while. Had to get that lamp positioned just right so that it's just over that hole there. And that was kind of a pain in the royal hind end just now. But I got it in place. Now I just need to get all this stuff reattached. Let's go ahead and get those soldered. Okay, just like that. All right. This is in, this is in, this is in. I got them all where they need to be. Perfect. Just making sure all my wires are not touching, resistors aren't touching. Batteries in there. But what I'd like to do now is just go ahead and we're going to put it on the dim bulb tester. And let's see what happens. I power this up. My light works. Give it a couple minutes. Alright, my meter is moving around there. Okay, zero adjust it. DC minus, DC plus. Okay, that's going to have to be. There's an adjustment for that. That shouldn't move. ohms. Alright, let me hook up some test leads real quick. Do a little bit of testing here. Here's my ground. DC. It's going to be AC. AC is blue. Let me. Alright, that's my AC probe. Okay, so let me. I'm going to go ahead, here's a battery. Okay, I'm going to go ahead. Let me measure that battery real quick. There's one out of my remote. Okay, 1.55 volts. My DC, ground, go to DC plus, 0 that, put that on, oh, let me put it on 5 volt scale. Okay, about 1.55. Alright. Try the DC minus. I'm supposed to have a 1 meg ohm resistor here, by the way. Okay, that's about 1.55, closer. But yeah, I did notice that because of the 0 adjust, I'm probably going to have to do some calibrating on this. Okay, so I know DC works. Ohms. Let's check my ohm scale. Oops. Alright. So check ohms. Ohms is on the AC probe. So let's go ahead and... There we go. Now 0 adjusts that. Ohms adjust for max deflection. Zero. Max deflection. Alright. Okay. So I'm on, oh there I am, R times 10K. So at 10K ohms, this is about 50K. It should be 47K. 47.5K. Okay. And I'm showing right at 50K ohms. Pretty close. Pretty close. I mean, can't complain. This one here is a 32 ohm resistor, so I gotta bring that way down. R times 10. 32 ohms. Okay, pretty close. Alright, well, ohms works, shoot, AC. Let me go to AC volts. I'll do 150 volts. Now I'm going through the dim bulb tester, so there's resistance, so it should be less than 110. I know the ground or the neutral's on this side, so there we go. And I'm reading 150 volts. It's about 100 and About 102. No, about 104. Okay. So I know all my functions work. I'll go ahead and button this up. Alright, so I want to go ahead and get these knobs on here. Found these knobs. These are not the original, but they'll work. Okay. Knobs on. There you have it. 1960s RCA WV-77E VoltOhmyst. So we now have a proper working VTVM. However, one of the things that I really want to do to this thing is I want to get rid of that battery. And you can do that with a little circuit called a battery eliminator. And it installs inside, and I have to tap into the circuitry in order to put that in there. So I'm going to produce a separate video that shows you how to install a battery eliminator in a VTVM. And along with that, I need to make some proper test leads for this. I also need to do an alignment. So I'm going to include that all in a separate video later. So if you liked today's video, please hit the like button. If you'd like to see this additional video or some of my other videos, please hit subscribe if you haven't already done so. In the meantime, happy restorations everybody. I hope you have a great day, and I hope to see you next video. Goodbye.